people who don't have them, you can sit with someone who has it. Okay, and we also talked about that when you are sitting in the exam, when you are doing any assignments, okay, don't think of it that it is done, so I don't have to think about it, okay, because you have to keep in mind that the mistake which you made in the exam, you can make the same mistake in the real life as well, okay. So in the exam you will lose marks. In real life you can lose what? Lives. And what else? More important? Money, right? Who cares about that? Huh? That's why you are here, right? You don't care about your life. Huh? Okay. Right now you don't care about the life and money, both. Huh? Okay, let me enjoy my life. Okay, anyways. Another problem can be that you may get into legal problems. Okay, your client, your boss, your community can sue you. They can take you to court and they can, cancel your engineering certificate, license, whatever. Okay, so the consequences will be very serious. Okay, and you will realize that it is the same mistake I was making in my student life. Okay, but I didn't pay attention because that mistake only cost me 1 mark. So I still got A minus without that 1 mark, which was good enough. Okay, but that same mistake in real life can cost all these things. Okay. Okay, now we will talk about some specific courses. You may have taken some of them, you may not have taken some of them. Okay, but you may have looked at your course plan, your study plan, so at least you know about their names. Okay, for example, there are courses which are related to hydraulics. Okay, so anything which has hydraulics written with it, it deals with what? Huh? Yes? Fluids, water, right? Okay. So in these courses, you are basically looking at how to calculate the flow rate of water, the pressure the water or any fluid can exert, okay, and so on and so forth. Okay. How it will affect your design. So if you don't know the correct way to calculate the pressure and flow rate of water, your pipelines will get damaged very quickly. Okay, because those pipelines are supposed to be designed according to the pressure and flow rate of water. Okay, so they can get damaged. So I'm not talking about that something will hit them and that then they will get damaged. Okay, water pipelines, oil pipelines. Okay, I'm talking about drinking water, for example, or the water which you use in your taps. Okay, so those pipelines do not have dirty water in them, right? They are not supposed to have solids in them. Stones and rocks are not supposed to be in them. Okay, same thing with the oil pipelines. They are not supposed to have solids in them. Okay, so they do not get damaged because of any hard object hitting them. Okay, they mainly get damaged because of the pressure and flow rate of the fluid itself. Okay, so if you did not pay attention to these types of courses, you may end up designing a pipeline which gets damaged very quickly. Okay, and one of the problems with pipelines, okay, where are the pipelines? Where are they? Underground, right? They are somewhere hidden, right? Okay, so when they get damaged, they start leaking or something. Will you know about it immediately? No. So a lot of damage is already done when you know that there is a leakage, there is a problem. Okay. Another problem can be if you do not calculate the flow rate properly, or if you are designing it for sewage water or some other type of fluid which has solids in them. Okay, like the waste, okay, wastewater and so on. Okay, and in that case, the flow rate has additional solids with it, right? Okay, so in that case you have a problem of blockages. And blockage will create more pressure and again pipeline leakage and damage and so on. Okay, so the problem is when pipeline gets leaked or something, you don't know about it. Okay, so for example, if you have a pipeline which is going through the floor or into the wall and it is leaking, you don't know. So what happens to that wall or the floor? Huh? Cracks. Okay, it starts swelling up and so on. Okay, so it's not only removing the pipeline. Now you have to change the entire thing as well. Okay, in some cases the water, or let's take the example of oil. Okay, if an oil pipeline is leaking, okay, obviously it is underground. So oil goes where? Where? The leak oil goes where? On the ground, right? Okay, so then it will damage what? People? Nature, environment, okay? The plants, the species which are living there. Okay, the oil is not supposed to be. Okay, you may have seen or heard about the oil pipelines, which there were some oil ships. I don't know, I forgot the year, but there was a time where some oil ships were damaged in the sea, and the entire oil was. It happened in Karachi, and it took like months to clear all the oil because obviously it's not easy. Okay, so it damages the environment. Okay, it is causing harm to the people, it is causing harm to the property, and so on and so forth. Okay, and all this is related to what you are learning in the courses of hydraulics. Okay, and you also have to when you are looking at these the design, are you designing for today? Then for when? How many years? How many years? You are going to design a villa. So what life you are expecting for the villa?
50 years.
50 years?
Yeah,
40, 50 years? Okay. Same thing with the pipeline, sir. Same thing with the roads. Same thing with the bridges. So you don't have to think only about now. You have to think about in future. And in future, population will increase, demand will increase, flow rate will increase. Okay, environment will change and so on. So you have to look for all these different things. Okay, then there are couple of courses. If you take the electives as well, then there are like 4 courses which are related to highways. Okay. So in those courses you basically see how we can design the highways, and the most important element of the design of the highway is what? Anybody? The thing which you like, right? Speed. Need for speed. So again, whenever we are talking about design, we are not talking about now. Okay, we are talking about again 20, 30, 50 years. Okay, and in highway design, the construction is in stages. The life of the structure is in stages. So the entire highway is not for 50 years. You may have seen even on new highways, they do maintenance, right? So they remove the topsoil, the top layer, and they put a new one, maybe after 4 years, 5 years. Okay, but the bottom layers are still there. Okay, so some layers are for 5 years, some other layers are for 10 years, some other layers are for 50 years. Okay, so it is in stages. So the entire thing does not have one lifespan. It has different lifespans. Okay, so now you can see the problem. I have to design the bottom layer for 50 years because for 50 years I will not change it. Okay, but the top layer I can change after every 10 years. Okay, so I am considering something different here and different here. The demand after 50 years is not the same after 10 years, right? Okay, but whatever happens after 10 years, I have to put it over the same old layer. Okay, this layer which will not be changed for next 50 years, it has to be workable for 10 years and 20 years and 30 years and 40 years and 50 years. Got it? Okay, clear now? Okay, I'm just telling you the problems, the issues which you may face while you are trying to design the highways, okay, and obviously we are looking for speed, right? We're looking for speed. How much is speed? How much is speed?
Depends on
Yes. How much is speed? Huh? 120? Okay, the next time drive at 120 so you can reach on time. Yes. Now, who else was saying this?
the length,
Depend on the
length,
length, okay?
topography of
Topography,
depend on the curves.
depend on the curves. If you are the driver, forget about you are not an engineer. You are a driver.
Curves with the engine.
Huh?
Curve means the engine.
Okay. In which universe? Yes, if you are the driver, what speed you will settle? This much is enough. Yes. You don't drive? Then 200. See? 200, then you jump to 100. 200, 100 is nothing. 200, 100, nothing. Yes, 200 plus 100, right? 300. Huh?
100 maximum.
100 maximum.
Same.
You are wasting your life. Okay. But if there was a road which can allow you 200, you will go ahead. Why not? Yeah? Why not? Agreed or not? So the things which you are saying, curves, topography, blah blah, the driver doesn't know about these. He is just looking at a plain road in front of him or her, and he will or she will go as fast as he can. He likes, she likes. Okay, got my point? Okay. So your design speed is not his concern. Okay. So the main point is the human element, the people who are driving. So you are designing the road for a speed of 100, 120 because there is a curve. So I am providing a super elevation, and the length of the width of the lane should be this much, so the driver can move easily. But what the driver is actually doing? Huh? He is driving and scrolling both, right? Huh? Right or wrong? Okay. So you are saying he has enough sight distance, people who have taken highway engineering. So you are looking, okay, they have enough sight distance, okay, even if they are going at 120 kilometers per hour, 140 kilometers per hour, I have given them enough sight distance, they can stop easily if something happens in front of them, okay, but you did not account for that they are not actually looking at the road, right? Okay, or they are already going at 160 kilometers per hour, not 140. Okay, so in case of highways, there is the problem of design life. You have to forecast for future, and you have to look for different stages of layers. Okay, how can I maintain this layer for 50 years, this one for 20 years? Okay, and there is an extra problem in this case of human element. Okay, people may overspeed, so they are not driving at the speed which you have designed for. They are not looking at the road. So when you are assuming that the driver will look at something and do this, you are assuming that he is looking. Okay, or he is following the lane. A big problem. Some places there is a big problem. People don't follow the lane. Okay, so whatever you are designing, that can change. Okay, another problem with highways and transportation is why do we travel? Why do we go from one place to other? Why don't just sit at home? Yes. Why do we travel?
For fun.
Huh? Yes, you for fun. Yes. You came here for what? To study, right? Okay. What else? For fun, for study. Yes.
See new places.
Huh?
See new places.
Seeing new places. Yes.
See you
see new people, and you get to see me every day. Waste of life, right? Waste of your time. You should hire someone new to, a new teacher in every class. That would be fun, right? Yes. What else? None of you is interested in work, right? New places, new people, fun, study. Nobody is working. Nobody wants to work. You go to gym, obviously.
Yeah, Jim also.
Gym also.
To know about culture.
To know about culture. He is in his own world.
Garage also.
He said about work. Who cares about work? Okay, but the one of the main reasons of travel is work. One of the main reasons of travel is work. When they say these many people, so you must have heard metro will start and these many people will use it daily, right? Okay, they give the plan, right? Okay, we will design it for 10,000 people, 8,000 will use it in year 1 and so on and so forth. Okay, so who are these people? How can I say that these people will actually use? Because they are counting on their work habits. People go from this location to this location on daily basis for work. Okay, this is the most common type of travel. Okay, and your work depends upon money, right? So if I get a better opportunity somewhere else, I'll go and seek my job there, right? Okay, so like in my case is like to another country, right? Okay, the people shift based on economic problems, okay, or economic factors. Okay, so when you are designing the highway, designing the transportation systems, you don't only look at what, okay, the demand is like this, and it will increase 1% every year. After 50 years, it will be this much. No, after 50 years, it can be double, or it can be half, depending upon what is happening in that area in terms of jobs and economics. Okay, so now they are developing new areas in Bahrain, right? New societies, new developments. For example, Askar and
New island, etc. New island,
New island
etc.
of Sitra. Okay, they are Marab, right? Okay, so these, before the new development, there is nothing there, empty, right? No activity. So if somebody is designing for what is happening now, I will blast your ears. Go there. I will blast your ears and hit your nose and everything. So my point was that for highway design, you don't have to look at what is happening now. You also have to look at what is planned for future. So after 5 years, this new development will be ready. Okay, so there will be a lot of traffic in that area. Okay, if you did not consider it, your design will completely fail. Got it? Okay, so these are the things we have to pay attention in the courses which are related to highway design. Okay. Yeah. Then, in terms of lab results, we already talked about what we are going in the labs for, okay, but how they are applied to the real life. We do testing in real life as well. Okay, the lab work or testing is not only for student life. So when you go and actually start working in the field, you will do a lot of tests. Okay, if you are the site engineer, if you are managing a construction site, lab testing is a regular part of your job. Okay, you have to go through it every day. There are organizations and companies which are solely doing the testing, nothing else. So they have their set of labs and they provide testing services. Okay, and they are also hiring engineers, right? Okay, so you have concrete on the site. The client said you have to test the concrete before you start using it. You tested the concrete, you got a value. What is the next question now? I tested the strength of concrete. My value is 20 megapascals. So what? Huh? If it's enough or not. Okay. So lab tests are done to check if my product, my material is as per specifications or not. Okay. So some of the tests are done in labs. Some of the tests are done on site. Okay. For example, slump test, right? Slump test is done. Just pour the concrete in a cone and you do the slump test. Okay. So they are done on site. Another thing which we have done, and I will consider as a part of testing, is survey. When you do a survey, some of the survey is just to collect data. But then there is another type of survey which you do on construction. That is also a test. You are testing if the road or if the building is according to the given dimensions or not. This is also a sort of a specification, right? Okay. So lab testing is required there. If you find a problem in your test results, then you have to make a decision. Your decision can be, should I stop the work, find out the problem, correct it, and then restart the work? This is one of the decisions. Okay. It will take obviously some time, it will take a lot of effort, it will have some losses because you have to stop the work, you have to pay the labor and all. Okay. Another decision can be, I only did one test, maybe there is a problem with this one sample, let me repeat the test before I make big decisions. Let me make sure that this is what is actually happening. I'm not following the, okay. So that's why I gave the example of surveying. Surveying, you take multiple observations. Okay, for the same location, for the same, you used to call it reading, I don't know what you guys call it. Like for the same reading, you do multiple observations. Okay, just to make sure that this is the value you are getting before you start doing something more. Okay, so another decision can be, I will retest to increase my confidence, to increase my reliability of the tests. Okay, or in some cases you are not within the specification, but you are very close to it. So in that cases, and sometimes we just ignore it. And they give you a margin. My specification is this much, but if you are plus minus like 2%, 3%, you just ignore it, move forward. Okay. So these are decisions you make on the basis of your lab works. Okay. So in engineering, we are not just solving equations, we are making decisions. Okay. In all these examples, I told you the decisions you have to make, especially in terms of design. Okay. So when you are applying the engineering, you are applying your knowledge to something which is real, something which is a real issue, a real problem, and you are trying to solve it by making responsible decisions. Okay. And in the end, whatever decision you make, you have to be accountable for it. Accountable means what? I told you earlier. Accountable means what? Responsible.
Someone asks you.
Yes, yes. To be responsible is a part of being accountable, but accountability means that I have a reason for it. Okay, I have a reason for it. It's not purely judgmental. Okay, it's not purely opinion based. Okay, this looks good, this looks bad. No, why? Okay, so this is what we mean by accountability. Okay, so let us do one activity, group activity. Okay, you can sit in groups. Okay, we have already taken some of the courses, right? I gave you some of the examples, but they were from the higher courses. Maybe none of you have taken high exam. Okay, so in your group, you will pick a course which you have already taken, and you will give me 3 examples of how this course is applied to real engineering. Got it? Clear? Okay. Pick one of the courses in your group and you discuss how this course will help in real engineering, in real life civil engineering. Okay. And then you make your points and you upload it, right? Clear or not? So you make your groups. Okay, a major problem for when students graduate, we already talked about some of the problems earlier. Now we are talking about problems which are related to the students specifically. Sorry. Which is the lack of confidence. Okay, I had a group of senior design students. One of them worked the entire year. He was the one who was coming to me for the meetings always. He was the one who was going after the data always. He was the one who was always, if I say you have to do this in the report, like he was the first guy who will act upon it. He may ask someone for help and so on, but he was the main guy of the group. Okay, and there was another guy who I did not see. He told me that the guy who was coming, he told me, yeah, we have a third guy, and his name is this. Yes. Okay, and that third guy came at the end of the semester, at the end of the year. Okay, and you know what he came up with? He said, Doctor, I prepared something for the presentation, something very interesting. I will start with the story. Like, what were you doing the whole year? Doesn't even care about it. Fine. I did not work on the project. Fine. I don't know what was happening in the project. Fine. I did not come to the meeting. You are looking at me for the first time in the project. Fine. Let me tell you, I have a story for the project presentation. Okay? And during the presentation, that guy who worked the entire year, he was like, the other guy was, tall and big. Okay? And the main guy, he was like going behind him. Okay? For the question, answers and so on. Okay? So, the problem is not he didn't do anything. Okay, the problem is he was lacking confidence. Okay, so a lot of graduates, a lot of students have the problem of lacking in confidence. Okay, one reason of it is you try to memorize things. Okay, you think that if during the courses, you try to pass through them by memorize. If this comes, this is the answer, and so on and so forth. Okay, in the last previous week, I talked about knowing something and understanding something. Okay, so I know this thing is negative, this thing is positive, but why? Okay, this thing goes backward, this thing goes forward, but why? Okay, so if you understand, then your confidence is also high. Okay, like I'm not saying to be that guy who didn't do anything throughout the project and throughout the year, and he was still confident I will do it. Okay, that's a skill. Yeah, if you can have it, fine, good. Okay, but is this something which you would like to be? You are thinking, right? Why not? No? Sleep the whole year and then come out like a master in the end. Why not? Huh? But honestly, no. Right? Why we want to be that guy? The problem is not with that guy who was confident. The problem is not with that guy who was confident and didn't do anything. The problem is what? With who? The other guy who did everything but didn't have the confidence. Got my point? Okay? So we want to be that guy who has skill as well as confidence. Okay? He can work skill is not the right way to put it. He, he can work or she can work, and she or he has the confidence to show it as well. Okay, this is what we are saying. So confidence comes from where? Confidence comes from understanding, first of all. If you understand something, then you are more confident about it. Okay. We already did one activity, I will not do it again, do another one. The thing is that if you ever tried introducing yourself, okay, to a group of audience, okay, and then saying something more about any topic, anything, okay, so the introduction part is always good, and the other part is always slightly low, on the lower side, okay, because in the introduction part what you are saying is coming from inside, right? Nobody can deny me, nobody can argue with me on this, right? Okay, so the confidence comes from understanding, okay, first thing. Secondly, you have to, like the activity which we did right now, this was a part of building confidence, because if you have passed a course, if you have did something and you know how it will be applied in real life, how it will be applied in real life engineering, okay, then you feel you are ready, and then you feel that, yeah, and then you will feel the confidence as well, okay. Many a times, and this is why we started this discussion, many a times students don't feel that what we have done in the class during the degree will help us in the real life. They don't see the connection, okay, they don't see the connection. So when they enter an office, when they go in front of a boss or in front of a client, they are already feeling that I don't know what is going to happen here. What the point? Okay, so you come in the class every day, you know what is going to happen here, right? Dr. O'Neill will shout louder and louder, okay, he will blast our ears and he will bore us, okay, you know this, it happens every day, right? Come on. Okay, so maybe in the if you remember how you were in the first few lectures in the university or in the school, that was difficult. That was different than what you are now. Okay, because you already know what is going to happen, and you know that this is what I'm going to do here. Okay, so connection with the real life of your studies. Okay. Another thing is the link between the courses, okay, and this is something which our program, the BSc program, is certified by an organization, an American organization which is called as Abbott. Okay, it is an organization which does certification for engineering programs all over the world. Okay, so many of the GCC countries are certified. Okay, this is considered a big thing. If you are not certified by Abbott, your program is not considered so good. If certified, considered good. Okay, especially in this region. So they put high emphasis that when the students graduate, okay, in their final year, they should see how the courses are connected and how they are preparing them for the final output. Okay, so how material is connected to mechanics, how mechanics connected to fluid mechanics, okay, how physics is connected to material, how, and so on, so forth. Okay, so there is a chain, so you should understand the chain, okay, how each course prepared you for the next one. Okay, so you see the linkage between your courses, and the last thing is exposure to the industry during your student life. Okay, so that's why we have the training course. Okay, so the main point of the training course is to give you direct and real exposure for the industry. Okay, but that happens only for 2 months in the whole 4 years. Okay, so if you get more chances to expose yourself, you attend lectures, you go and for site visits and so on and so forth. Okay, whatever chance you can get, you should avail it, because once you are familiar with the environment, you are more confident. Okay, anybody when they are in the new environment, they are more cautious, they are more careful. Okay, they may think 10 times before they speak. Okay, but if they keep on going to the same environment, even the person who was very shy and who is still shy will be more comfortable in that environment. Okay, so whatever he was on the first day will not be the same after 2 weeks. Okay, so he will improve somewhat. Okay, he will not remain the same. Okay, so try to get as much exposure as possible. Okay. Okay. The next thing we are going to talk about is social responsibility. Every professional has a social and ethical responsibility as well. Okay. So one of the most important aspects of responsibility of a civil engineer is something which we call as sustainability. Okay. Now some of you already have the notes in front of you, right? Okay. So there's a definition of sustainability written there. Can everybody have a look? Just look what is, so you will see the slides for social responsibility on slide number 2. You will see the definition of sustainability for civil engineering. It's a long definition, 4 or 5 lines. Sorry? In this slide? I didn't have to look at it. Why are you guys looking? Are you still looking there? I'm trying to find it. Okay, no problem. I forgot. Okay. See? That's why I'm here. Not in the field. Okay, I didn't upload the slide, who cares? Okay, anyway, first of all, let us look at, so I have to summarize it, I cannot read through it. So accessibility first of all, civil engineering is what? Civil engineering is all related to what? What is the main aspect of civil engineering? Huh? Civilization. Yes. Anybody else? Yes. Civil engineering is all about providing what? Providing what to the civilization? Infrastructure, right? Okay. So we have discussed it earlier as well. We deal with all aspects of provision of infrastructure. That includes planning, design, construction, maintenance, okay? So operation, okay? So all provision of any type of infrastructure and all stages of provision are dealt by civil engineers, okay? So when we are providing this infrastructure, our product, our service should meet the needs of the society, right? Again, something which we discussed a number of times earlier, okay? In engineering, we are trying to solve problems, right? So we are providing infrastructure because there is a need for it, okay? So this is all about civil engineering right now. We are trying to solve a need by providing infrastructure, and we deal with all stages of the provision, Got it? Okay. Now, sustainability comes when you are talking about future. Okay. Sustainability is related to the future of the society. Okay. Not just the current needs, but the future of the society. How do we incorporate sustainability in our infrastructure business? Okay. So, first of all, whatever we are providing must not be harmful for the environment. Okay, the damages to the environment because of our construction, because of our design, should be at a minimum. Secondly, we cannot spend resources extravagantly. Okay, something which can be done more efficiently with less time, less money, less resources, we should go for it. Okay, I talked about earlier, there are always multiple options for the same thing. Okay, you can make a steel bridge or a concrete bridge. The cost will be different, material requirements are different. Okay, you will look at the efficiency. Okay, which one is more efficient in terms of resources. But keep in mind, this comes first. This comes first, then this. Okay, and it should support the economic and social life of the people. Okay, so this is linked again. Okay, so our infrastructure should not be harmful for the environment, should not consume too many resources unnecessarily, and it should support the economic and social life of the people. Okay, economic life means they can benefit from it for their business, for their work. That's it. Okay, I already gave the example of what? Okay, the travel. Okay, the infrastructure which you are using for travel, it is helping you with your economic needs, right? Okay, you go for work and so on, and the same can also help you with your social need. Okay, you said you came here for what? Study, right? Studying is what? Nothing. Huh? Nothing, just what our parents ask us to do, right? Yes, studying as a social need. Social need. Yeah, it's economic as well. Okay. It's a social need. Okay. Okay. So yes, in the end we want to get employed and so on, but during your study is considered as a social need. Okay? We will consider it as economic need. This is for us. This is for you. Okay. Hospitals, for example. Okay. Anything related to health. You go and what? Meet new people, or new people, new places. Okay, and so on and so forth. These are all what? Social needs. Okay. So sustainability is linked with all of them. Okay, but you are not talking about now. We're talking about how it will affect future generations. Okay, so and this has happened a lot in the past couple of centuries, where people were going for industries. Okay, so when they were going for these industries and more cars and more machines and so on, they were not thinking about these things. Okay, so now we have shortage of gas and natural resources. Okay, people are talking about recycling. So now they are talking about recycling now. Why? Because we already consumed so many resources, right? So when the people who were doing it at that time, they didn't think about this, or they didn't think about it enough. Okay, otherwise we will have less of these problems, right? Okay, so sustainability means in civil engineering that you are building the infrastructure which is safe for today. Okay, and it is affordable for the client and for the society, and it will it will sustain in a safe way, in a less harmful way for the future generations. Okay, this is what sustainability is all about. Okay, so for example, some examples of including sustainability in the design is, yes, you design buildings which consume less electricity. How? How we can design buildings which will consume less electricity? Yes.
Put some solar panels.
Solar panels. Okay. Anything else? Good. What else? How can we make buildings consume less electricity? Huh? New. Okay. LED. Okay. Huh? Location of the light. Yes. Location of the building itself.
If you put it in places, hot places, or that's we consider that there is a lot of sunlight inside of the building. We will need more conditioning or something like this. So this is also
Yes. By this idea, there should not be any building in Bahrain, right? Too much sunlight throughout the year. But anyways, you get the idea, right? You can use insulation, you can use natural ways of ventilation and light and so on. Okay. You can decide about the materials which are more durable. That's why we are using concrete so heavily. Okay, because concrete is durable. Okay, it can sustain for many years. Okay, so even if you are having more cost now, it will last for many years. Okay, so yes, the time aspect. And yes, yeah, they are, if the design of the building can itself attract heat, okay, if not designed properly. Okay, they are, for example, when people go for these glass, now you have seen the glass facades, right? The glass walls and so on. In modern buildings they use this, right? The whole wall is made up of glass. Okay, so or any material which you are using on the outside of the building. Okay, if that material is absorbing heat and inside you don't have any ventilation, like in most of the cases what we have, AC. Okay, so then it's closed. Okay, so your material which is exposed to the sun, it is absorbing heat, and inside you don't have any circulation of air, so you are trapping heat. Okay, this is what they call as heat islands. Okay, so buildings can become heat islands if not designed properly. Areas can become heat islands if not designed properly. Okay, some of the populated areas which have high-rise buildings in Bahrain, they are like heat islands. Okay, you just enter the area and you start feeling the heat more. You are in Bahrain, you feel the heat, but more. Okay, because these buildings with their glass facades and with their even with the so much air conditioning. Okay, so they are giving cool air to you, but they are what they are giving outside. Heat, right? Okay, so less use of them will be good for the outside area. Okay, so you have to think about that as well. So water resources, we already talked about hydraulics. Okay, so if you design your water pipelines and water systems properly, it will save leakages and damages. Okay, and I already gave you the example. If there is leakage, you do not detect, and the water is being wasted. If it is wastewater or oil and it is going into the ground or into the sea or into some natural body, that it is destroying the environment. Okay, so this is all because you did not design it properly. Okay, we use now, we do recycling of water as well, right? We recycle water as well, and we use it where? In plants, right? In irrigation plants and so on. So that recycling system is also designed by civil engineers. Okay, the recycling system. Before recycling, you have to collect this water somewhere which is safe and which will not damage the environment, right? Okay, so all these things are done by us. Another thing which we experience like once in a year, okay, with heavy rains, right? Okay, it happens. I believe it is happening more regularly now in this region. Whenever there is a heavy rain, you see a lot of what they call as surface flooding, road flooding. Okay, so throughout the year you don't have like a single drop of water on the road, but for that 1 or 2 days, you cannot even move your car. Okay, the water can be so high. So who is supposed to design the drainage system? The civil. Okay, if you are not designing it properly, then water damages your structures. When water accumulates on the structure, road or bridge or whatever, if it is not drained fast, it destroys it. Okay, one of our teachers used to, he gave, I don't know which subject, but he gave an example that there are 3 damaging factors for the road. 3. Okay, water. Okay, he took it from some Japanese guy or something. Okay, but you get the idea. Okay, so then when roads get damaged on yearly basis because the drainage system is not proper, that means you are wasting your resources, right? Okay, you can drain the water and use it for something else. Okay, so we want roads that last longer. Okay, they don't have these problems and which require less maintenance. So we need to use materials and we need to do the construction in such a way that the maintenance cost is very low, because in terms of roads and transportation, when you are doing the maintenance, you have to stop everybody, right? Okay, so you are disturbing people, you are causing them delay, they have to go from other roads, they will disturb other people as well. More congestion means more fuel, more damage to the environment, and so on and so forth. Okay, yeah. Another thing which is now becoming very popular is sustainability in your travel habits as well. Okay, so all of you came here by car, right? All of you? Okay. If somebody says, okay, why don't you use a cycle to come here or walk here? What will be the biggest problem? The distance. And what else? The heat problem, the weather. Okay. So how can we sort out? Now people are planning the cities in such a way that everything is within a 15 minutes walk. There are 15-minute cities in the world. They call it 15-minute cities. Okay. We are having a presentation from Korea. They said we are not from Korea, Singapore. They said we are designing our cities because we know our people's habits. Okay. So we are designing 20-minute cities. Everything is within a 20-minute walk. So it requires planning and design. And who will do it? Like you guys. You guys. Okay. Materials, a lot of you are talking about materials. So you talk about cement, we prepare cement, right? Preparation of cement is a very heavy process which causes damage to the environment. Okay, it needs a lot of resources. Another thing which we use very often is aggregates. Aggregates are natural materials. You have to do mining for it. When you are doing mining for it, you are damaging the environment again. It's something natural which you are disturbing, right? Okay. So you have to see or look for materials which will cause less damage to the environment. That's why we are going for recycling and so on. Okay. And we try to manage the waste as best as possible. Okay. The last example is managing the project. Project management. Okay. So project management directly deals with this thing, resources. Okay. How do you control the budget? How do you control the cost of the project? Okay. So if you are not managing the project properly, you will have delays, you will have extra costs and so on. Okay. So in the end, you have to make sure that whatever you are providing for the society is safe, accessible and fair for everyone. Okay. Important point. Sustainability, you are benefiting one group and you are harming the others. Okay, lot of rich countries, they have their waste which they dump in other countries, or they dump in a way that it does not accumulate there. It goes from their country to somewhere else. Okay, it happens a lot. Okay, and people in poor countries, they basically buy these things on low prices, thinking that we will reuse them, but those things are already damaged. So it's basically dumping your waste. Okay, so you need to be fair when you are considering sustainability. Okay, and I already mentioned you need to think about future. Clear? Any questions? Thank you.